Hello students, this is Poonam teacher back with a new video of Science 1. In my previous video, I have taught you extraction of highly reactive metals. So in this video, we'll be studying extraction of moderately reactive metals. Now this moderately reactive metals appear into the middle of the reactivity series, and those are some iron, zinc, lead, copper. So these are some moderately reactive metals. Moderately reactive means not very highly reactive, not very low, and they will not possess even the low reactivity. So that is why these are placed into the middle of the reactivity series, and that is why these are known as moderately reactive. And most of these metals, they are found into their they appear or they are extracted from their sulfide ores or carbonate ores. That means the metals are going to be associated with sulfur. That means they'll take the form of a sulfide, or these are present along with the radical CO3. That is why they'll take the form of the carbonate, like iron sulfide or iron carbonate, zinc sulfide or zinc carbonate, lead sulfide or lead carbonate, copper, and then so on. So like this, it is easier to obtain the metals from their oxides. So first you have to convert this sulfide ores or the carbonate ore into their oxides, and then it is very easy to reduce that oxide and to extract the metal or to obtain the metal. Then the process in which the sulfide ores are strongly heated into the presence of air is known as roasting. And I've taught you in my previous video about the calcination, that the carbonates are strongly heated, or any ore, if it is heated into limited supply of air or into the absence of air, that will be known as calcination. So carbonate ores are mainly these are heated into limited supply of air or into absence of air. So this is known as calcination. So see what kind of reaction takes place over here. So in roasting, if you are taking any sulfide or like zinc sulfide, and then you are heating that ore into into sufficient amount of air, so air will surely consist of oxygen, then that sulfur will be dissociated from zinc, and then it will be associated with oxygen over here, and then such kind of products will obtain, that is zinc oxide and sulfur dioxide. And then in the process of calcination is applied for the carbonate ore. So for example, if you are taking any zinc carbonate ore, then that zinc carbonate will be heated into limited supply of air or absence of air, and it will result in the formation of zinc oxide, and carbon dioxide gas will be evolved over here. Now the zinc oxides obtained is reduced to zinc by using suitable reductants such as carbon. Now it is easy to reduce the oxide, so you can use any reducing agent, or reducing agents are also known as reductant. I hope that you know the meaning of reducing agent, as I've taught you this before. So reducing agents are those substances or those compounds or those elements which itself undergoes oxidation, but these are going to reduce another reactant which is present along with it. So here carbon is going to be the reducing agent or the reductant. So it will get oxidized itself, it will get associated with oxygen itself, but it will make this zinc alone. That means the zinc has been reduced over here and carbon has been oxidized. So this is how it will result in the formation of zinc, and carbon monoxide will be evolved. So here carbon was a reducing agent. Then apart from carbon, reactive metals such as sodium, calcium, aluminium are also used as reducing agent for the reduction of metal oxide to obtain the metal. And it is very sure that if any reactive metal is present along with any normal metal, that reactive metal will try to take the position of that metal, or will try to grab another radical which is associated with it. So here I can show you one example, that manganese is less reactive than that of aluminium. So when aluminium came in contact with the manganese dioxide, that aluminium took the place of manganese, and manganese was left alone like this. So here it resulted in the formation of manganese, and aluminium oxide was formed, and some amount of heat has been evolved. That means it is an exothermic reaction. So this is how, when you are using any reactive metal for reducing any metallic oxide, then also the work can be done, because that reactive metal will try to reduce that metallic oxide, and then you can obtain the metal. So this is how the things will take place. Now here you have to identify that what has undergone oxidation, what has undergone the reduction. So here Fe2O3 is there, that means ferric oxide, and here aluminium is there. Aluminium is more reactive than that of iron, and that is why now aluminium will get associated with oxygen radical over here. It will form alumina, that is aluminium oxide, and iron will be obtained, or iron will be left alone, and some amount of heat will be evolved, so it is going to be an exothermic reaction. So in this reaction, iron has been reduced and aluminium has been oxidized, and aluminium here acted as a reducing agent.